Hi, my name's Andy Young and I'm one of the lecturers down at Unitec in Auckland. I teach automotive, and one of the previous videos that I produced was to cover and test the charging system on your car. Now we're going to look at the alternator itself, and we're going to actually go through and test each of the individual components that make up the internals of an internal regulator rectifier alternator. So here we go. Once you've pulled the alternator apart, and they're not too difficult to do. Sometimes you need a puller to get the rear casing off. But inside, you will find a number of components. And we have, first of all, built into the casing is the stator. Now the stator is made up of 3 separate windings, and each of the windings is connected at one end onto one of the terminals. And if you can see quite clearly there, look, this one here has got lots more wires going to it. Okay, these other ones have only got 2 wires each, and that one has got all the wires going to it there, look. And that's the common. And we label these up A, B, C, and terminal D. And we're going to be testing that a bit later on. And we also have a rotor. Now inside the rotor, and we cover this in greater detail later on, is a single winding. That's one piece of wire that's wrapped around and around and around the central core, and then each of those ends of wire are connected to one of these 2 slip rings. Now these slip rings are completely worn out. You can see it's all damaged and stuff, but that's what they are. They're the slip rings. And essentially a 12 volt supply, a variable 12 volt supply, is applied to this circuit, and that creates an electromagnet. Now on that electromagnet, we have the different poles. These are called the claw poles, and we've got the south and the north, or it could be the other way around. It could be north, it could be south. It all depends on which way we send the current around that winding. And we'll look at that a bit later on. Other components inside the alternator, well, we've got very simply a set of brushes. You're probably quite familiar with those. And those brushes are a wearing component, and those brushes run on the slip rings. Oh, they run on the slip rings like that, look. Okay, and they transfer the current, which is stationary on this part, bolted to the casing of the alternator, onto the rotating shaft here. We also have a rectifier unit. Now we need to have one of these because the current that's induced into the stator is AC. It's alternating current. And that's of no use to us on a motor vehicle, on a car. So we have to have a device that will change that to a DC current. And to do that, we use a rectifier, and we'll be looking at that in greater detail a bit later on. And finally, the other main component, and sometimes these 2 are built together. Fortunately, in this one, they're separate, which makes it a bit easier. We've got the regulator unit. Now, this regulator unit, its sole job is to control how much current is fed into this electromagnetic winding. That adjusts the field strength of that magnet, which therefore adjusts the amount of current induced into the stator windings. So we have a means of control. This can sense battery voltage or sense the voltage within the loom, how many ancillaries are turned on the car, and basically it'll see the volt drop, and it'll instantly increase or decrease the rotor field strength to control the output of the alternator, so we don't overcharge the battery, for example. So there you go. These are the components, the main internal components of an alternator. It's not normal these days for a garage to take these apart. It's just not really viable cost-wise. The labour content to pull them apart is quite high these days. You can buy the components, the individual components normally. There's 1 or 2 alternators now that you can't. You've got to buy a complete alternator. But in the main, you can still, if you're prepared to take the time to source it on the net, you can get the various bits and pieces that you need. Some of the tests that we're going to be doing are quite simple. We're going to be testing the resistance of the stator windings. We're going to check the resistance and continuity and so on of the rotor. They're a real simple thing to test. When it comes to testing the rectifier unit, we need to have a multimeter with a diode tester on there, and again we'll be showing that later on. This little baby here, the regulator unit, is much more difficult to test, and you do need a piece of specialist equipment, which is that one there that I borrowed from Unitech for the day, and that allows us to test this unit. Now, in addition to that, we're going to have a heap of wires and connections to make onto the correct pins on this regulator unit, and to know which pins are which, the transfer unit comes with a 407-page manual, which is huge, which allows you to identify which regulator unit you've got, and it tells you the connections to make. Without that manual, it's very difficult, and obviously without the specialist equipment as well, it's very difficult. So, for you guys at home, what I suggest that you do is you test the stator. If you're going to pull an alternator apart and attempt to fix it, you test the stator, you test the rotor, you can test the rectifier unit. It's quite simple, and of course you can do a visual check on the whole unit as well. I mean, things like slip rings and stuff, they would need to be replaced if they're in that kind of condition. They're definitely not serviceable, they're completely worn out. If everything else checks out, then you can assume that the regulator unit has gone faulty, and you'll need to order a new one of those. And they're not too hard to order. There are, let's have a look there, look, there is a part number on there, sort of, what's left of it. You can also match it up with the alternator number as well, the sticker on the outside of the alternator, and you can visually identify them as well. They're all, they're all very different, and it's pretty obvious which is which. Okay, so we'll make a start now testing the various components. Okay, so the first test we're going to do is to test the rotor. Now, obviously, before you make a start, we're looking for faults which are going to render this unit non-repairable. So instantly on this particular unit, the slip rings are completely worn out. That's these two copper-coloured units here. These are the contact points of each end of that winding that's inside that rotor, which makes up the electromagnet. Now, they're completely worn out. They can be replaced. There are companies out there that will replace them for you, or if you've got a lathe and you're really, really good, you might be able to make some up yourself. But assuming that everything on the outside looks good, then we can do a very quick and easy test using our trusty multimeter. Now, the multimeter needs to have an ohms setting on there, and you've seen this one before. There you go. And we're going to turn it round to ohms, which is just on there, look. Click, click, click. There we go, ohms is on. And we need to set the range, at the moment it's on mega ohms, we need to set the range to just normal ohms. So to press that, we go on to there, look. There we go, normal ohms, and I'll just turn the light on as well for you, the backlight. There we go. And we're all ready to take some readings, so we'll hook that on there for you. Now, on one of the wires for this particular test, I've just put a little crocodile clip on there, which makes it a bit easier while I'm filming. And we're going to clip the earth wire, doesn't matter which one really, onto part of the casing, the steel work of the rotor. Now it can be onto the fan or onto one of the claw magnets, or whichever, it makes no difference at all, as long as it's connected to the main shaft. Okay, now the test we're going to make is to put the other one of our probes onto each of the two slip rings, and we should get, or we need to get, open circuit. If we get any kind of reading at all, it's an indication that the insulation of that winding on the rotor has broken down somewhere. It's got damaged, and it's leaking down to earth, down to ground. So what have we got? No, we're all good there, and we're all good there. Now I always test both, because it might be that the winding has actually got broken as well, and only half of the winding is going to earth. So always best to test both, and that will be a pass. We're all good with that. Okay, so the second test is that we need to check the winding, the electromagnetic winding inside the rotor. And to do that, quite simply, we keep the meter on exactly the same settings, and I removed the crocodile clip off the earth. So now I've got just the 2 probes, and we put 1 probe on each of the 2 slip rings. So I'm going to try and do that single-handedly, so you can see the meter. You've got to make sure you get a good connection on there, because otherwise you're going to get a point of high resistance and a false reading. We've got basically 3 ohms result, which once we've deducted the resistance of our meter leads, and to do that you just clip them together like that, and we get, let's see what we get, 5, half, very little, so nothing to worry about there. Okay, so we've got a reading of 3 ohms as the resistance for that winding. Now, if the resistance was very high, if the reading we got was very high, then it would be an indication that maybe there's a bad connection between that winding and one of the slip rings, or the wire itself has got damaged, it's got crushed somewhere, and it's only just touching rather than being a complete break. If we got an open circuit, so OL, which is what was on there, that's what we get when there's no circuit, as we are now. Look, the leads, the test leads are not touching each other, so you get OL. That will be an indication that the winding, somewhere along its travel, and it's probably a couple of 100 meters long, is that wire, has become broken, and it's not one continuous circuit anymore. It's not going to work as a circuit. There's going to be no current flow, and therefore we get no output from the alternator. Now, if that was the case, if the resistance was high, it turned out to be slip rings contact onto the winding, then if we're going to replace the slip rings, then we could fix that at the same time, not a problem. If, however, it's within the actual unit itself, and we can't really get into there, you can separate them, but it's not really worth the hassle. Plus, these rotors to buy separately are usually about 80% of the cost of a new alternator. So if you find a fault at this stage with it, and it's not the slip rings which you are feeling you could replace, then this alternator will be deemed as scrap, and you'd have to go and get a new one. Okay, so that's the 2 tests that we need to do. Obviously, every alternator is different. Some will have larger electromagnets on the rotor than others, depending on the output of the alternator. But as a general rule, somewhere between 2 and 6 ohms reading for the resistance of the rotor winding would be classed as a pass for most car alternators. So that's the rotor tested with the trusty old multimeter set on ohms, and we're going to move across now and we're going to test the stator. Okay, so next test is the stator, and the stator essentially is a static winding. It doesn't move around. It's got basically 3 windings in this one, and as the rotor rotates within this round winding, and it's got an electromagnetic field, as those fields cut through each of these windings here, each of these loops, they induce a current. Now, because the electromagnet has got alternating poles, you've got north-south, north-south. I'll show you again on these claws here, look. So we've got the various claws. So as that's spinning around, we've got loops of magnetic field rotating around with it, and those are cutting through the stator. So what we end up with is an alternating current being induced into these 3 windings. And that alternating current needs to be converted to DC. An AC current is no use for charging up batteries and so on, and to running car systems. So we have a rectifier for that, and we'll come to testing that a bit later on. But in this stator, we've got essentially 3 windings. Now those 3 windings, like I said earlier on, each of those windings has a common point on this, the way it's wired up, and we've got them all coming together on terminal C, the common terminal. The other end of those windings goes to one of these 3 here, so we've got A, B, and C. Now the test is really quite simple. Okay, so before we start the test, I've fitted our trusty crocodile clips back onto the test leads. Now obviously that's going to add some resistance to the whole unit, so we can just retest that now. And we've got, what have we got? Give it time to settle down. It's made hardly any difference at all. Okay, that's great. Perfect. So I'm going to put one of the test leads, doesn't matter which one, onto the C terminal, the common terminal, where all three of the windings join together. The other one I'll put onto terminal A, and we'll take a reading. Now, again, make sure you've got a good connection because it's important you get good readings. Bad connection, point of high resistance, is going to affect the tests. Now, the result we're looking for is 0 to 0.2 ohms. These windings are made up of pretty thick copper, single strand copper wire, and they have a very low resistance, which is a good thing. Whilst you're doing the test, you can also have a little look and do a visual inspection and see if any of the insulation on these windings has got broken off. It's a lacquer type insulation, so it's like a paint and it does crack off. It's not usually a problem if there's nothing going to be touching that winding. If it's on an area where it's in contact with the casing, then we're going to have a major problem. We'll come to that test next. Okay, so the result for winding A was 0, or near as damn it, 0 ohms, which is obviously a pass. Winding B, give it a chance to settle down again. Seems to be a bit slow, this meter. Yep, again, we're well within spec there. And finally, the third winding, which comes out on terminal D. And again, where are we? Half an ohm. You may get some discrepancies. As long as it's within spec, we're all good. Yep, okay, so we're well within spec on that one as well. Great. Okay, so the second test is to make sure, or to test the insulation of those windings. We don't want any of them to be going down to earth. Remember, these windings here have an AC voltage induced into them, and that AC voltage is usually between 90 and just a little bit over 100 volts AC. So, you know, that's the same as you're going to get in some domestic power supplies in houses. In the UK we get 240, but in America and so on it's 110, I think. So that you can get a good shock off that, and it also can spark down to earth, down to ground, which is going to cause a lot of heat. It's going to cause alternator output failure, and it's going to be the demise of the alternator. It's going to create more and more and more damage to the whole system until the whole thing fails. So again, to do this second test, we just take one of the leads, clip it onto the casing of the alternator, and then we can just whiz around and check onto each of the 4 terminals. Now, we're looking for open circuit, and on this particular meter that stands as OL, so basically whenever I'm not touching anything, we get OL, no circuit. So hopefully we're going to continue to get no circuit on any of these. And it looks like we might be in business. Okay, that's cool. So the stator has passed both tests. It's passed, each of the windings has passed the resistance check of 0 to 0.2 ohms, and we've also, the stator itself has also passed the insulation test to make sure that none of the insulation is damaged and the current can flow, the current that's induced could flow down to earth. So on this particular alternator, the stator is actually in really good order, so it's a pass. Okay, so the next test is to test the rectifier unit. Now, its job is to convert the AC current that comes out of the stator from AC, which is 90, 100 volts AC, coming in on 3 different windings, into a single phase 12 volts, 14 volts, 14.5 volts, 14.5 volts DC output. And that's what comes out of the alternator on the big thick wire. And that's the B post terminal there, look. You see that? Okay, so that's the terminal that we connect the thick wire onto the alternator on the car. And that goes into the loom and it powers all the ancillaries and the systems on the car, such as the fuel injection system and the ignition system and everything, the lights, the lot, okay? And it also charges the battery up. So if the battery is really low on charge, low state of charge, then additional current will flow to the battery as well to top the battery back up to maximum. And it does this by using a number of diodes. Now, most of you all know what a diode is. It allows current flow to travel in one direction, but not in the other direction. And these are basically assembled are wired up in a particular circuit which we call a bridge rectifier. It's very common, lots of generators and so on use them, and of course it's in alternators as well. And this bridge rectifier unit, rectifier unit, we need to be able to test each of the diodes. Now it is possible, if you've got a duff diode, to be able to replace it and put a new one in there. So I'm going to move the camera so you can actually see me doing the testing, because it's a bit difficult as you are now, and we'll see if this is going to be a pass or a fail. Okay, I'm here, don't panic. New camera angle for you, just going to do a voiceover on this because it's a bit hard to see. The first job is I've put, again, one of our trusty crocodile clip leads onto the common lead of the multimeter. And there's 4 separate tests on here because we've got to check the diodes both ways, and there's 2 sets of diodes. We're going to put that onto the B post. Now, with the positive lead, just get it untangled, very unprofessional. Okay, with the positive lead, we now need to go around each of these 4 outputs. Now, these are the terminals that the 4 wires off the stator connect to. All right, so we just connect that onto each of those, and we should ideally be getting between 0.5 and 0.7 volts, but it does depend on the alternator. And what I'm going to do as a spec is, if they all end up being about the same, then we can assume that it's going to be a pass. So we're just under 5 volts on those 3. Yeah. Okay. Good. So that's a pass. That's the first of the 4 tests passed. Now what we need to do is check that there isn't current flow in the other direction. So we now put the positive test lead to the battery B post, the output, and we do exactly the same. And this time we should get open circuit. So we should have OL. Now, just to prove it's working, if we just tap it onto there, we get a reading. So we know the meter's working properly. We should get open circuit on all 4 of these terminals. And again, make sure you get a good connection, because it's these test connections that can make all the difference. Okay, so that's a pass. We're happy with that. Now I'm going to reconfigure, and we'll do the second 2 tests. Okay, so the second batch of 2 tests, so to speak, is we get the common lead for the first one, and we put it onto here, which is essentially ground. So onto there. Okay, so we're making a nice good contact on there. And then we take the positive lead, and we need to go around each of the 4 contacts again, and we should be getting, again, open circuit. We don't want any current flow in that direction. Okay, 1, 2, 3, 4. Perfect. Okay, so all that's also correct. Now all we need to do is swap the test leads over. So we'll put the positive lead down to ground, and we'll use the negative lead, and we'll do the same test again. And this time we should be getting that sort of 0.47 volts ideally again. Oh, there we go, look. Okay. Fantastic. Okay, so in actual fact, and I'm quite surprised about that, this rectifier unit is serviceable. There's nothing wrong with it, all the diodes. Okay, so a quick summary then, because it's always best to see face to face. With the rectifier unit here, we've tested each of the 8 diodes in both directions for current flow. That's what the 4 tests were about. And as you know, a diode should only allow current flow to be in one direction, and it should resist current flow in the opposite direction. And that's how a bridge rectifier basically works. I'm not going to get into that. That's not what I'm teaching today. That's from our theory lessons. But this unit has passed the test. If it hadn't done, then if you're feeling really keen, you could maybe source a new diode and you could solder it in, fit it into the unit. They're only a few cents for one of those. Or, which is most likely, people will go out and you just order a new one of these. And there are part numbers shown. It's a bit not very clear, but there is a part number in black ink on that unit, and you'll be able to go online, and there's plenty of companies out there which will happily sell you just one of these. And then you can reassemble your alternator and you should be all good, provided there's no other faults. So that's how to test the bridge rectifier, and we used a multimeter and we used it on the diode setting. You must have a diode setting. Now, let's just put the light on for you so you can see better. All right, press that. Now, the diode setting is, there's 3 functions available on that one position for the dial, and to get to the diode setting we just press select. Okay, and there it is. There's the diode setting symbol. Sorry, it was hiding in the camera. Once you see that, then you know that you're on the correct setting, and that's what you need to use. Don't just use the ohm setting, you must use that, otherwise you're not going to get correct readings. Okay, so we've now tested, so far in this video, we have tested the winding in the rotor, the electromagnet, which is varied in strength by the regulator unit. We have also tested the stator, and the stator is made up of 3 separate windings which all are joined at one end, and we've done resistance checks on those windings, and we've done a check on the insulation to make sure that none of the insulation is damaged, where any current that is induced would end up going down to earth, which would be a problem because it would affect output, and it would also create damage to the alternator. There are some brushes to test. Well, brushes really, the only thing about brushes is a visual check on the condition of the brushes and the brush length. Now, there should be at least 6 millimeters of brush protruding when it's not under, when they're not compressed, they're under no tension, the springs, protruding from the casing to the end of the brush. And again, clearly you can see that these brushes have worn out. There's probably about 4 mil there. Again, these units are quite easy to buy, and if you were going to be replacing the regulator unit or the rectifier unit, then chances are you're chucking a new set of brushes in while you're in there. Obviously, with this particular alternator, we've got problems with the slip rings. They're completely worn out. They would need to be replaced as well. So at the moment, this alternator, the only problem with this alternator is the fact that the slip rings have worn out, so we need new slip rings, and we'd chuck a new brush pack in there at the same time. The other main component that we've not tested yet, which I've left till the end, is the regulator unit. Now, the regulator unit is very difficult to test. You need specialist equipment for that. Its job is to control the current flow into the electromagnet on the rotor. That's going to control and adjust the field strength of that electromagnet. Now, as you probably know, or may not, that there's 2 ways that the output of an alternator is increased or decreased. If we, first of all, when we rev the engine, the alternator speed, the speed that the rotor spins, increases because it's connected to the crankshaft via a belt. At idle, the rotor's turning relatively slowly, about 600 to 1,000 RPM. Maybe a bit more because the pulley size is a bit small on the alternators, maybe let's say 1,500 RPM. And as each of those fields cuts through the stator, it's going to induce some current. Great. And if we kept the field strength the same and we rev the engine, then the output of the alternator would shoot right up. It would increase dramatically. But we may not want to have that many amps output coming from the alternator. So the regulator unit, as the speed of this rotor increases as we rev the engine, the regulator unit would automatically reduce the current supply, the feed, to this electromagnet to reduce its field strength and compensate for its increase in speed, and therefore regulate the output of the alternator. The same also happens if we're sat at the traffic lights and we suddenly turn on the headlights. Then there's going to be a volt drop in the circuit. The regulator unit will sense the volt drop, and it will increase the field strength to increase the output of the alternator to compensate for those headlights being on. So the regulator unit is constantly working all the time. Whenever the engine revs change, then it's going to be adjusting, reducing or increasing the field strength of this rotor. Whenever the consumption of the vehicle's demands on current change, whether they cooling fan flicks on the radiator. We turn on the indicators to make a corner. Put the headlights on because it's getting dark. We're getting cold in the car. We turn the heater on. Whatever it is, we plug our phone in to charge it up. Any changes in the demand for current on the car, again, the regulator will sense that by sensing loom voltage, and it will adjust the electromagnet accordingly. So the regulator unit actually is working all the time. It's pretty busy. It's always doing stuff. And it has a little heat sink on here because it does get pretty hot too. Now, to test the regulator unit, we need a specialist piece of equipment. Okay, and this one here is made by Transpo. It's an American unit, and I'm going to show you, well, we're going to test this unit. I don't expect you guys to have one of these. I don't even have one of these. Unitech does. I'm quite sure they're quite expensive too. If I ever get a chance to get my hands on one, maybe at an auction or somewhere, then I would snap it up because it's a very useful piece of kit. But like I said earlier, you do also need the manual. Now, for this unit, the manual is available online. So if you see one of these and there's a garage or a workshop that's gone bust and you're at the auction, you see one of these units or something similar, then snap it up because it's invaluable when it comes to testing regulator units. Now, obviously, most people won't have one of those, and in which case you need to test everything else in the alternator, and all of that checks out good, or it's things that you can easily fix. Right, no, sorry, if it all checks out good, then, and you know there's no output from the alternator, then realistically you're going to have to assume this is faulty. And they're not massively expensive, so it may be worth a punt. On an old MR2 that I was working on the other day, I managed to get a whole brand new alternator for about 300 bucks. If this was being faulty, it's probably worth 50, 60 bucks for one of these. It's worth a punt, put it in, it should be fixed, provided there's no other faults on the alternator. If there's other faults as well, and on this one it needed slip rings, it needs new brushes, yeah, I could probably have ordered all the bits and pieces and fixed it, but hey, I don't have time, I'm busy making videos for you guys. So there you go, regulator unit. I'm going to set up the Transpo now, talk you through how it all connects, and we're going to see if this unit is faulty or serviceable. Okay, so according to the instructions for the Transpo kit, I've set everything as it should be. I've done this quite a few times now in the past, and the regulator unit, although we're getting the correct output voltage of 14.6, and it's been wired up in accordance to the diagrams, and this is an example of one of the diagrams that you would get in the Transpo book. So you can see it's a bit of a mixed match of wires and bits and pieces. The most important thing that I've found that students tend to make a mistake on is the earth wire, which is the one under here. You can see down there, look, I don't know if you can see or not, but it has to go onto a little tab, the little earth tab. There you go, it's just moved for you. Okay, that must go onto the earth tab. If it doesn't, then you're not going to get any readings at all. Yeah, they're a bit fiddly to wire up, but as long as you follow the instructions, it's actually pretty simple to work out. Okay, so I was just going to run through with you connecting up the Transpo machine, the Transpo tester, and you might be able to see there on the diagram. I have done a close-up of that earlier on. We've got the diagram which shows us which wires go where on these particular regulator units. And it's a bit, I agree, it's a bit fiddly. There's a lot of wires going into a small space, and you've got to make sure that you keep contact with each of the clips. Now, I always start with the positives. We've got the main battery positive wires here, and this branches out into three because they go into three different places on the regulator unit. So first of all, you can see on here test rig ignition wire, and we're going to put one of those onto there. And where else have we got those? Okay, we've got one on the other side as well, so we'll pop that onto there like that. They're not particularly supple, these wires, so you've got to be careful. Like I say, always make sure you get a good connection. There's no point in rushing this, because if you get bad connections, you spend half your time trying to find them. And then the other positive goes on to here, look. So that's the third positive. All the same, being supplied the same voltage. And again, just make sure you get good contact. Now, whilst we're in the plug, we'll finish off. We've got the green test light. That's the wire that comes off the alternator that goes to the battery light on the dashboard of the car. So we're going to be testing that that works okay. So we'll pop that one down there. Now obviously it's really important that none of these wires touch each other as well. You've got to make sure that they're all insulated, otherwise again you're going to get the wrong readings. Okay, so we've only got a few left to go. The yellow test lead, which is the field wire, and that one goes onto there. Looks a bit different to the diagram. Put it on there like that. And then we've got the stator wire, which is the stator output. That's the white one. So we'll pop the stator wire onto there. Now, lastly, we've got the earth wire. Now, this is really important. Underneath the regulator unit, and I'll show you again later on, there is a little metal tab, and that earth wire must go onto that metal tab. Okay, right, we're all on. So now we can turn the power on. And there we go, it started to work. Brilliant, bit of a delay. We should be getting about 14.5, maximum 14.6 volts. One fault with the regulator unit is it can fail and it can overcharge the battery. It can fail to regulate the voltage supplied to the rotor. So that in the end, the rotor ends up working at full power, the electromagnet, all the time, which then gives us maximum output from the alternator. So we end up getting an overcharge situation which boils off the acid in the battery, and it can also cause other component damage. The flashing light indicates that the unit's working correctly. This is essentially the warning light inside the car on the dashboard. That's the battery light simulator on the machine. And that lamp should be illuminated all the time whilst the test is, or whilst the machine's turned on and connected correctly. And as you can see, it's not. And that tells me, and that was one of the faults in the car as well before we fitted the new alternator, is that the battery light wasn't coming on, even during engine not running but ignition turned on. So that's an indication that this regulator unit is in fact faulty. And I think I made the right decision in just buying a new alternator in the end, because to have fixed those slip rings, to fitted new brushes, and to have fitted a new regulator unit, you know, with all the hassle and the extra work and the cost of getting the correct parts and the time involved in sourcing them, realistically I would have been better off just getting a brand new alternator and getting the 12-month warranty. You've got to remember that the other components in this alternator are also old. You know, you've got things like bearings and things which are going to be pretty worn. We've got obviously you know, some damage, some insulation damage, although it's not causing a problem on the stator. So even if I had fixed this alternator, I may only get another 6 months to a year out of it. And if any of you have ever worked on an MR2 before, replacing the alternator is a nightmare of a job. So for peace of mind, on this particular occasion, I just put a new one in. And now that I've tested the components, it turns out I made the right decision. So if you have one of these transport machines, then they're very, very useful for testing regulator units. If you haven't got one, don't panic. It's not the end of the world. As long as you test all the other components, then, you know, if the alternator hasn't got an output and you know that all the wires going to the alternator are in good order as well, then you can assume that the regulator unit has gone faulty and that would need to be replaced. Don't let me put you off fixing your own alternators. That's not what this video is about at all. It's actually to give you an insight in what's involved and not to be too scared about it. You know, worst case scenario, you pull your old alternator apart and you can't put it back together, then you're just going to end up buying a new one anyway. But at least you've got some experience about taking one apart and you've now got an idea of how they actually work. Okay, so I've shown you how to wire up the regulator unit. I'm just going to, and we've done the test, I'm just going to disassemble all the wires and show you that tab that the earth lead needs to go onto, because that's one of the common mistakes that students make when they're wiring these things up. So we'll turn the power off, just disconnect everything again. There we go. Disconnect that. Pull that out of there. Okay, so just to show you, this is the little tab here which the earth wire needs to be connected to. Okay, a lot of students in the past have clipped it onto there. It's the wrong, doesn't work. That's the earth tab. It must go onto the earth tab like that, so we get a nice good connection. Right, so that pretty much comes to an end all the testing on the internal components of an alternator, an internal regulator alternator. We've covered the rotor we started off with, and that has a single winding inside, and we've tested both the resistance of that winding and the insulation on the winding to make sure it's not going down to earth, which will be a problem. We've also done a visual inspection of the slip rings, and as you can see here, these ones are completely stuffed and need to be replaced. Then we moved across and we did some testing on the stator. Now the stator is a static set of 3 windings which have current induced into them by the rotating electromagnetic field of the rotor. And that voltage is an AC current, it's an alternating current voltage, and it needs to be converted into DC for it to be of any use to the vehicle, so we can charge up the battery and run the vehicle systems. And to do that, we use a bridge rectifier, and that's what this thing is here. And we tested the diode pack in there. We tested all 8 diodes to make sure that current, basically that they were operational correctly, that current flows in one direction but not the other for each of the 8 diodes. And that was a pass. Okay, as was the stator. No problems at all with the stator. That was a pass. The diode pack, the bridge rectifier was a pass. The rotor was a fail on the slip rings, but it was a pass on everything else. We also inspected the brushes very quickly. We just talked about those. Pretty obvious that they're worn out. They need to be a minimum of 6 millimeters. But realistically, if you're going to pull an alternator apart, these are the fastest wearing component inside an alternator. Really, as a matter of course, you should be putting a new set of these in every time. And then we finished off with testing the regulator unit. Now, to test a regulator unit, you need a specialist tool, which essentially is one of those. Okay, there are other brands out there as well. They're not cheap, and in all honesty, not many garages have them, never mind mechanics that work from home or DIY mechanics. So, as long as you've tested everything else, and you're sure that the circuits on the car are in good order as well, there's no broken wires and stuff, then you can assume that this is the component at fault. You don't need to test it. It's the last thing left. If the alternator's not working and everything else has tested good, then you're going to need to replace this. And then, fingers crossed, your alternator will be all fixed. And these are relatively easy to change. I mean, these alternators are quite simple to pull apart. The biggest problem is splitting the casing, but you don't need to split the casing to get to the various components to test them. You can test them with the alternator together. You just take the rear cover off. That's that piece there. You just take that off, and that gives you access to all the test points. We don't need to split the casing. We don't need to expose the rotor. So, you know, within 10 minutes, an M8 spanner, a little screwdriver, you've got the bits that you need to do the various tests. Sure, you know, if you're going to be replacing slip rings and stuff, then yes, you've got to split the casing. But for diagnostics, to find out how much is wrong with the alternator, very simple to get to. Okay, well, I hope you found that video helpful. It's good to talk through how an alternator actually works inside and what role each of the various components plays. My name is Andy Young. I'm one of the lecturers, the automotive lecturers down at Unitec in New Zealand, and I find making these videos for my students, and these are all the jobs, all the tasks that we do in the workshops during practical lessons. I find making videos of these particular tasks and showing you how to do the jobs to be very rewarding and helpful to my students, and hopefully helpful to you as well. Because you can watch the videos over and over again. You can watch each test procedure one at a time. You can replicate it, see what results you get, go back if you're not too sure, watch it again. and that's the beauty of e-learning. So thanks for watching. Cheers.